This is John Kerner, and today I'm going to go through one of the new features in Visual Studio 2015, which is the Diagnostics window. So I have a little application here that I wrote, and what this application does is it has it's just a console application with a string that it creates, a couple hash sets, and then a big loop. And inside this big loop, it creates new strings and adds them to that hash set. So basically, it's never releasing those strings. So it creates a bunch of strings and never releases them, and they're going to be ever-growing strings because it keeps appending to the string. And then I create a worker class. I do some work with it. Then I add that to a hash set just to keep those around for a little bit. Add a little sleep here just to slow things down so we can diagnose it before we completely run out of memory. And then I have inside that worker class the doWork method. Every 500th iteration, it's just going to throw an exception. So it's just going to throw an argument out of range exception. We're actually just going to catch it and do nothing with it, just to demonstrate some of the functionality that the Diagnostics window has. So when you start up the Diagnostics window, or when you start up your application, the Diagnostics Tools window will pop up, and depending on your Visual Studio configuration, it'll pop up in different places. Looking at this, you can see my memory is growing very quickly already. I've been running for 12.5 seconds, and I'm already over 200 megabytes. I'm going to just pause here real quick. So looking at the Diagnostics window, you can see some of the information that it provides to you. So these little yellow ticks here on the memory tab are different spots where the garbage collector ran, and actually if you hover at the right spot, you can see how long it took to actually do the garbage collection, if it was a forced or unforced garbage collection, and the generation of garbage collection that it did. So it gives you a little bit of information about the garbage collection that's happening. You could use this information to, the fact that garbage collection happened to indicate, if you see a drop in memory after the garbage collection ran, then maybe, it's just normal memory usage of a .NET application versus our situation where it just keeps growing no matter how many times the garbage collector runs. You'll also notice here the red diamonds. These red diamonds are what are events, and these Intellitrace events, and these Intellitrace events can be used to dig into more information about what's happening. So these red diamonds actually indicate exceptions that were thrown, and so those are going to represent the exceptions that were thrown as part of our, that worker process that we had. So what you can do is you can actually use this to zoom in and out. So you could zoom in, and let's go back to the beginning of our application. We can see, right at the beginning, we actually have, you can kind of see it, but you can't really. So I'm going to zoom in a little bit more. And right over here, you have two diamonds. You have a gray diamond, which is the diagnostics were loaded. Then you have exceptions that were thrown, and they are displayed down here in the Events tab down below. You can click and drag in here and select only a set of events that you want to see. And so right now we're looking at from 0 to about 12 or 15 milliseconds of time. And we can see that there was an Intellitrace event for the loading of the accessibility.dll into the app domain, and it gave you some information that it can't find or open the PDB file, and then an exception that was thrown. On exceptions, you actually have the option of going into what is called historical debugging. So historical debugging is exactly what it sounds like. When you click on it, it's going to take you to the location where the exception was thrown, and it's going to give you some historical information about what was the state of the application at that time when the exception was thrown. So we can look here and we can see that in our locals, it indicates this is historical debugging. I can see the value of I is 0 at the method entry, and I can see that the exception that was thrown. I can also go over here to my call stack and see that what the call stack was at the time that the exception was thrown. So I could go in here and I could look at the call stack, and I can see the args that were passed into the application. And you could walk actually all the way up your call stack here and gather information about what was happening to help you figure out what's causing the exception. And since you have all the arguments to the functions, if you're writing unit tests, this is a great way to write a unit test to ensure that you don't get the exceptions in the future. If you are not seeing this historical information, if you're not seeing the arguments, you may have to turn on the Intellitrace setting to actually show those. So if you go under the Tools Options, and under the Intellitrace tab, there's a General tab, and you make sure you have Intellitrace enabled, and you want to make sure you specify Intellitrace Events and call information. Doing this does cause a performance hit to your application, so you may only want to use this when you're actually debugging a reproducible exception that you want to dig into a little bit. Otherwise, by default, it's going to be the Intellitrace Events only. So turn this one on if you want to get the historical debugging with the method arguments and call information. So the method arguments into each call of methods in your application. So I'm going to go back here. I'm going to reset my view, just get back to where we were. And I'm going to now focus a little bit more on the memory tab. So if we switch over from the events tab to the memory usage tab, right now there's nothing in here. So what I'm going to do is I'm going to start my application back up, continue, and it's starting to consume memory again. And I'm just going to use this take snapshot button. So I'm going to take snapshot, and I'm going to do this a couple times. And then I'm going to pause, and I'll take one last snapshot at the end here. So what you can see is this snapshots give me a point in time the memory usage of my application. I can see the number of objects that are in use. I can see the size of the heap in my application. If you'll notice, these are blue. I can actually click on any of these and say, okay, show me the I'm going to want to see the number of objects in memory at this snapshot 5 that we have here. So you can see I'm working on snapshot 5, and I can see that I have 13,904 worker objects that have been created. I can also see that it's using 166K. So this is probably not the cause of the memory leak, but I am leaking objects, so it's something I probably want to address. I could also sort by the size in bytes and see that this one big hash set is using up 758 megabytes of RAM. So this is probably my culprit and where I should focus on my time to free up the memory. The other things you can do in here is you can compare this. So if I want to compare snapshot 5 to snapshot 2, I can compare it, and it's going to give me the deltas. So it's going to show me, how many new worker objects were created, the size difference between the two snapshots. I can again sort by any of these fields and see that my hash set grew by 175 megabytes over the time between snapshot 2 and snapshot 5. And if we go back and look, snapshot 2 was taken at 24.19 seconds and snapshot 5 was taken at 29.919 seconds, so those were 5 seconds apart. So in 5 seconds I ate up 175 megs of RAM. Obviously there's a problem there. If you're looking for specific objects, you can actually use the filter. So you could actually go into this filter here and just say, show me all workers, and hit enter, and I can see that only the worker objects that are of type worker or have worker in the name are showing up here. I can clear that, and if I want to, I can actually drill into the hash set. So if I double click on the hash set, I can see all the instances of the hash set. I could select on one, and it's going to show me the paths to the root. So it's going to show the parent objects that reference this object. So I can see what's holding on to this object. If I'm trying to find something that's holding on to the object that I was expecting to be freed, this is a great view to have to figure out who's holding on to it. There's also the referenced objects, basically showing what this object is holding on to. And here we can see that it's holding on to a bunch of strings that are eating up 758 megs of RAM. And then I could actually drill into any of the strings here, and on any of these, I still have the the memory preview option that I had available to me. You have available to you through normal debugging. So this is just a great way to investigate memory usage of your application. You could also go back and look at one of your worker objects, and you can see all the instances of your worker objects go in there, and you can again see what's holding onto it. So we see it's being held onto by a hash set, and what objects it references, and this guy doesn't have any references, so there's nothing in there. So again, just nice views that can help you diagnose and troubleshoot your application. Inside of here you have the option to search values, so if you want to search for certain values inside of your worker class, you could do that as well. So as you can see, using the Diagnostics Tools to troubleshoot issues in your application and to find memory leaks and memory usage of your application is very easy with Visual Studio 2015. So if you like this video, please comment below. Thanks.